We are going to learn one of the most difficult concepts in Fusion 360. These are constraints. Learning and understanding constraints can be very difficult and takes a lot of time, but once you master them, you can truly begin to model successfully within Fusion. Constraints are essentially modifiers within sketches that define three things within sketches: position, angle, and length. Understanding how to define every part of a sketch's position, angle, and length is critical to modeling. If I create a sketch and make a line that isn't connected to anything, then the sketch is fully unconstrained. If we drag one of the ends of this line, we can see that the length and the angle changes. This means that the length and angle are not defined, since I can change it by dragging it around. If I grab onto the main part of the line, I can drag it around as well. This means the position is also unconstrained. Our objective is to fully constrain this line with mathematical constants. I'm going to delete this line and make a new line. This time, I'm going to make its starting point on the origin and drag it out. Once we do this, we can drag this line around the origin and see that the line's angle to the horizontal can change, as well as its length can change, meaning that this sketch is partially unconstrained. But we notice that it always pivots around this point, so its position is constrained relative to the origin. Now, we're going to constrain this line. We're going to make a new line on the origin and drag it out. Press Tab to edit the angle. We are going to set the angle to 45 degrees. Press OK, or press Enter. Now we see that this line, the only part that we can change is the length, meaning its position and angle are constrained. To fully constrain this, we will use the Dimension tool and give it a distance. I'm going to give it a distance of 15 millimeters. And then we can see that it is fully constrained. The only way that we can change anything with this is to change our parameters, such as changing the angle to 55 degrees or changing the length to 25 millimeters. We'll also notice that when we create a line like this, it also creates a secondary construction line. This construction line's distance is unconstrained as well. We can constrain this by giving it a dimension itself. The Dimension tool is the main tool in our arsenal for constraining objects. It can be used to define a length, a position, and an angle, as well as a distance between two objects. All other constraints are just some derivation of the Dimension tool. The first one we have already used, likely without realizing it. This is the horizontal and vertical constraint. If we delete everything and create a line from the origin going up, you will see this icon, which is two lines and parallel lines going out of it. This means vertical. If we create a line like this, the line will always stay vertical, and it will have this icon to the right of it. The same thing happens if you go perfectly horizontal. Actually, this is a different constraint that's happening because of this line. But if we make it without touching another line, you will see that vertical pop up. The horizontal and vertical constraints can also be found in the Constraints tab. So if I make a line where the angle is not constrained and use the horizontal and vertical tool, which is shown here, and tap on the line, it will make it horizontal. And if I make it more vertical, it will snap to be more vertical. And once again, this constraint is automatically applied if you draw the line perfectly horizontal or perfectly vertical, indicated by that blue symbol. It is important to clarify the different types of shapes that you can create different types of constraints on. The default rectangle makes the rectangle's angle locked, which we can see with these horizontal and vertical constraints that are automatically applied. Other rectangles, such as the center rectangle, allow you to change the length and position based off of a origin. The last rectangle, 3-point rectangle, allows you to change all of the constraints, including the angles. As you can see, there is not a single horizontal and vertical constraint applied. This means different objects apply different constraints. The next constraint we are going to look at is the coincident constraint. We have also used this before, likely without knowing. Coincident essentially forces two objects to be connected to each other. If you create a straight line started on the origin, you will create a coincident constraint. This is where the endpoint of the line is coincident to the origin. If you click on the origin, you will see this symbol pop up. This means that it is coincident, and this means that that endpoint will always be connected to the origin. So that can constrain the position of this line. We can also apply this to two different points. For example, if we create two lines that are not connected, we can click the coincident constraint tool in the constraint tab and tap on the endpoints. We see that they become connected. This can also be applied to points on opposite lines. For example, I can make this endpoint coincident to this line. Now, it doesn't make it constantly touch the line, but it means it will always be collinear to the line. So as you can see, even though it's dragged out, it's still in line with this other line. The next constraint we will be learning is the tangent constraint. This can be applied between a circle and an arc and a line. A circle or an arc and a line. So if we make a circle and we make a line like this, the tangent constraint can then be applied between them. Similar to the coincident constraint, it doesn't mean that the line is touching, but it means that the line's plane will always be tangent to the circle. It can also be applied to arcs. The next constraint is simple. It is the equal constraint. This just applies a modifier to a line, circle, or arc that defines it as the same length as another line. If we make two lines of differing length and then apply an equal constraint, shown in the Constraints tab as this equal symbol, it will then make them have the same length, meaning that if one gets changed, the other also updates. This means that if you apply a dimension constraint to one, say make one 15 millimeters, the other one will always be 15 millimeters. This also updates when you change the constraint, or the dimension constraint. This can also be used on circles and arcs, pertaining to either the diameter for circles or the radius for arcs. As you can see, it has the same radius. The next constraint we will look at is the fixed constraint, which is this lock in the Constraint tab. We rarely use this constraint simply because it is not parametric, and it means no mathematical significance. It essentially just locks the position, angle, and length of a line without other constraints. This means that it is very difficult to change. If we take a line like this, It is not defined at all, since we can move it around. Its angle is not defined either, since we can change its angle, and of course its length can change as well. If we apply the fixed constraint, it will lock it into place, except for the length, though we can lock the endpoints to make it fully constrained. We will rarely use this constraint, and it is only beneficial when working with fit point splines, which cannot be constrained. So, like this. You cannot constrain this line, so what we do is we select the entire fit point spline and we fix it. This means that it is now fully constrained. The next constraint we are going to look at is the midpoint constraint. We have also used this before when we create a line with a point on the center of another line. It acts like a coincident constraint, except it has a specific location. To use this constraint, create two lines and apply a midpoint constraint to the endpoint of one of the lines onto the midpoint of another line. The next constraint we will look at is the concentric constraint. The concentric constraint is basically a coincident constraint between the midpoint of two different circles. So it makes them share the same midpoint. The last constraint we are going to consider is the collinear constraint. This is a combination of the coincident and parallel constraint, which we will look at in a second. This basically means that two lines will be locked on the same angle and the same plane. So you can see they are always locked in the same angle. Now, the last two constraints we're going to look at are very basic. They're the parallel and perpendicular constraints. If I make two lines like this and go to the constraint menu and select the parallel constraint, this will then allow me to make the two lines parallel to each other. This means that their angle will always be the same. If I lock its midpoint, if I apply a coincident constraint onto the origin, you can see how that angle changes. This applies the same way to the perpendicular constraint, which just means they will always be 90 degrees from each other, which you could see like this. It is always 90 degrees. It is important to consider that all of the constraints define some aspect of a sketch body. For example, coincident constraints can be used to define a position, since it pins a location to another object. Parallel can then define an angle, and equal can define a length. Therefore, using these constraints, we can define every part of a sketch.